Welcome back. So now we're going to be solving equations where we have a log equals a number. This is called, well, the technique we're going to be using here is called exponentiating each side. In other words, we're going to take this log equation and rewrite it as an exponential equation, which is the whole reason I taught you, well, one of two reasons I taught you how to rewrite log equations into exponential equations. Right? Because if we have log equals a number, this is much, much easier to solve as an exponential equation. All right, so if only one side of the equation is written in logarithmic form and the other side is written in exponential form, in other words, it's a number, there's no log. It's not log equals a log, it's log equals a number. We need to change the logarithmic side to exponential form as well. So we're just going to rewrite this as an exponential equation. So remember that I can't point and have you see it. So I'm going to draw a little arrow here. So my arrow is going to point for me. There we go. Now notice there was no base written here, right? No base means 10's the base. I put the 10 in here so that you would know how to write the equation. But base raised to a power gives us a result, right? And I even color coded this, right? So purple's the base, red's the exponent, blue's the result when we rewrite this in exponential form. Right? So we have 10 to the 5th power, base raised to a power, equals 3x plus 1. And I decided to put the 3x plus 1 first, right? Because that's where I got my x's. All right, so this was our base raised to a power. That's all we have to do to change a logarithmic equation to an exponential. All right, now we can solve. All right, this is just an easy, simple equation to solve now that we've rewritten it. All right, 10 to the 5th is going to give us 100,000. All right, and so now all I got to know is subtract 1. 3x equals 99,999, and then divide by 3. 33,333. Right? The checks on these are optional. Because when you exponentiate, you're raising a base to a power, you're not going to get a negative number. You're not going to get something that's false, right, automatically. However, if you just want to check your solution, it's pretty easy to do so that you can just check, hey, my answer is correct. And it may be a good idea so you don't forget to always check it when it's log equals a log. So we have 3 times 33,333 plus 1 equals 5. All right, so that would be log, that's going to be 100,000 equals 5. Well, that's a true statement, right? Because 10 to the 5th does equal 100,000. We know that because, well, we figured that out a couple steps ago, right? Plug into the calculator or just add 5 zeros. Or 4 zeros, right? So that would be a true statement, right? So you should only get true statements on these, no false solutions, right? Because we're not going to be getting a negative number no matter what our exponent is when we're raising a base to a power. All right, let's look at another one. And by the way, was this one in the notes? Indeed it was. All right, so you've got that one all in your notes. Let's look at the next one. And the next one is not in your notes, but the one after that one I believe is. All right, so we have, and I'll check this one just so you can see. We have log base 9 of 2x minus 1 equals 3 halves. All right, so I color coded it. All right, the purple's the base, the red's the exponent, and the blue's the result. Base raised to a power gives us an answer. We're going to rewrite this as an exponential, and then we'll have something really easy to solve. We'll just simplify the base with the power, and then we'll just solve for x. Right? It's not really very difficult at all. So we have 2x minus 1 equals 9 to the 3 halves power. To evaluate that, do not multiply 9 by 3 halves. Right? We're not multiplying it by 3 halves. We're raising it to a power. It's a lot easier to raise to the power if you rewrite that as a radical, right? Change that rational exponent to a radical, right? So it's always power over root, right? So 3 is the power, 2 is the root. Right? So we have the square root of 9 cubed. Since it's easy to take the square root of 9, you should do that first and then cube it rather than the other way around. Not that you couldn't, but it's a little bit easier. So we have 2x minus 1 equals the square root of 9 cubed. The square root of 9 is 3. So we have 2x minus 1 equals 3 cubed, which is 27. And so we just add 1 to both sides and then divide by 2. So x is 14. And we can check it out and see that it works. So we have log base 9 of 2 times 14 minus 1 equals 3 halves. So this would be log base 9. That's going to be 28 minus 1. That's 27. Log base 9 of 27 equals 3 halves. And now we can check it out. Right? We've got all the pieces there. Right? So is 27 to the 3 halves power equal to 9? Right? Well, that's the same as the, excuse me. Ignore that. Is 27 equal to 9 to the 3 halves power? I accidentally stuck it on the wrong number. All right, so our base is raised to the power, gives us an answer. All right, so if we rewrite this, it would be the square root of 9 cubed. And we just saw what that was, right? Square root of 9 is 3. 3 cubed is 27. Of course that checks out. Right? But you can always check it out and make sure you didn't make a mistake. But it's not a required step because you're not going to get a false solution on these ones. All right, so let's take a look at another problem. And so here we have, and this one is not in the notes, right? No. All right, so we have 2 times the natural log of negative x plus 6 equals 14. So if your logarithmic equation has anything added to it, we have to simplify that first, right? We have to, before we can try to rewrite that as an exponential, right? We got to get it all nice and simplified. All right, so that plus 6, subtract it from both sides. Right, because we can't write it into an equation with all this stuff in there. All right, so now we have 2 times natural log of e of negative x equals 8. Got to get rid of the 2. The easiest thing to do would be divide both sides by 2. The not so easy thing to do is return 2 as an exponent. I would just divide both sides by 2 and deal with it that way rather than returning it to an exponent. It'll be easier to solve. All right, so now we have natural log of e natural log. And I only put the e in there just to remind us of what the base is when we rewrite it. In reality, notice the e wouldn't be written in there. So natural log of negative x equals 4. Now I rewrite that as an exponential. My base is in purple, it's the e. The power is in red, that's our answer. And then the result is in blue. So e to the 4th equals negative x. And now it's a calculator problem. Raise e to the 4th power. I just went to 3 decimal places and divide by negative 1 to solve for x. X is negative 54.598. Right? So once you've rewritten it, it's a calculator problem. It's just simple, simple inverse operations and maybe a calculator. That's about it. Right? So the tough thing is making sure you rewrite it correctly. And I don't think it's that tough. I think you can. I have utmost confidence in you. All right, so here's one that we're going to solve together. It's in your notes. We have log base 5 of 3x plus 1 equals 2. Our first step, right, well, it's all isolated, so we're okay that way, is we need to rewrite in exponential form. We have, try to figure out what letters I've already written. We have log equals a number. All right, so anytime we have log, one single log equals a number, we're going to exponentiate both sides. We're going to just rewrite it in exponential form. So we have, and I like to have the 3x, this part here over here on the left-hand side because that's got my variable. All right, so that 3x plus 1 is equal to the base raised to the power. Right? So we have 3x plus 1 equals 5 squared. we'll just simplify that. That's easy enough to do, right? 3x plus 1 is equal to 25. And now we'll just solve for x. It's a simple equation now to solve. Once we've rewritten it, it's super easy. You subtract 1, 3x is equal to 24, and divide both sides by 3, so x is 8. Okay? And the checking is optional. If we checked it, right, we'd get 24 plus 1 is 25. And yes, 5 squared is 25. Okay? All there is to it on this one. Let's do one more. Right, so we have log base 3 of 2x minus 1 equals 3. Right, so our first step is to rewrite, since it's all isolated, rewrite in exponential form. Right, so we have 2x minus 1 equals 3 cubed. We'll simplify. 3 cubed is 27. And then we'll solve for x. Right, so we'll add 1 to both sides. 2x is equal to 28, and then divide by 2. X is 14. That's all there is to it. So of all of our problems that we've done, I think these are the easiest of all, even easier than log equals log. And that wasn't too difficult because I don't get any false solutions to worry about. All right? Is that my last problem? That's my last problem, because now we're going to look at one more type of problem, and that's where we have more than one log on a side. And so that's my next podcast. So see you in the next podcast. We're just zooming through these.